Here we go, thanks. So this is an introduction to Boscovich given by my friend over in Serbia, Professor Dragoslav. And the plan is I'm going to give a go through this. It's about existential crisis, and then there's a video of some experts talking about Boscovich by way of introduction, and then it's a Professor Boscovich, and at this time it would be Einstein, not Einstein, a few things about Einstein. Hi. So basically, there's an existential crisis that was caused by Galileo that which he plunged the church into, and which science and physics still suffers from now. This is Galileo, and poor Galileo, as we know, was persecuted by the Inquisition. But what is usually ignored is the church then tried to recover from the humiliation of silencing Galileo. So they managed to silence him. He went before the Inquisition. They told him to shut up about what he was talking about, and they put him under house arrest. So basically they won on a personal level against Galileo, but on a bigger level they shouldn't have won against him. So what the church then did was they put their top man on the case to try to sort out the mess from having won against Galileo, and this is their top man, who's Father Boscovich, who was from an area of the world which was once Yugoslavia. So I want to go to the first video by way of introduction of what some experts say about Boscovich.
Boscovich was born in the independent Republic of Ragusa, today Dubrovnik, on the Adriatic Sea. And together with another brother, he was educated by the Jesuits and became a Jesuit himself. Ragusa was an old republic, a republic that lasted for about 5 centuries, and was rigidly divided in 3 different classes: aristocratics, middle class, and lower class of workers. And the political power was in the hands of a very small aristocratic class. When Boscovich was 15, he moved from Ragusa, Dubrovnik to Rome, and kept being educated by the Jesuits, and studied and later became a professor at the Collegio Romano.
The Society of Jesus had a very important tradition in the physico-mathematical sciences, owing to the fact that mathematics had been included in the Society's teaching programs since the middle of the 16th century, while biological sciences and naturalistic disciplines in a larger sense of the word were forbidden by the Society constitutions. Loyola had explicitly forbidden to teach biological subjects because the canon law forbids clergy to exercise medicine. This was the root of this phenomenon. As for Boscovich, his position is partly strictly Jesuitical and partly original, in the sense that his training was entirely internal to the society tradition, but independently he was studying what was produced outside the society, mainly French science and Leibnizian science, and then also Newton. So that he mastered Newtonian physics very early, and when he, as a young man, became professor of mathematics in the Collegio Romano, he was able to introduce the more mathematized parts of Newtonian physics into his teaching. This was the beginning of his career, but also of his problems, because some basic assumptions of Newtonian physics were not only outside and against the Aristotelian principle, which were still taught by his colleagues in philosophy, but also against some basic tenets of the society's doctrine. Boscovich tried to conserve some of the basic tenets of the society within a new approach, a new doctrine, and this was his originality, but also the spring, the source of all the problems he met within the society.
This period is very interesting because up to the 50s, in particular up to 56, Boscovich elaborated his main ideas in the field of natural philosophy.
Boscovich created one original natural philosophy system who is, has deep inspiration in Newton's natural philosophy. I think that Boscovich was very profound reader of Newton, not only of Principia, but also of the queries of his optics. And it was very stimulating for him in earlier period, before his study of theology, for example, when he studied the phenomenon of aurora borealis, but also in a period when he created his own natural philosophy system, because in earlier treatises, De Viribus Vivis, De Materia Divisibilitate, De Lumine, we have a choice of excellent quotation of Newton. And we have also the documentation how Boscovich developed from Newton's starting points new building, something what Boscovich called New World in his correspondence.
Yes, I think his main work, the Theoria, published first 1758 in Vienna and then in an extended version in Venice 4 years later. Basic law was such that it allowed a very large variety of combinations of these puncta, of these elementary particles. And this explains the huge variety of forms and properties of matter we find in nature, going from the smallest entity up to living organisms.
In the introduction to the Dragoslav's talk, so what the church has done is they've built science on Aristotle, and Aristotle is the father of logic. And Galileo had thrown all that into chaos with his observations. So he got some of the priests and that looking through the telescope. Right, the church had tried to dominate science and they had started to learn the importance of observations. But they built their logic on the observation of things like sunrise and sunset. So you observe that and you think to yourself, well, the earth isn't moving and it's the sun moving. So they had built to a large extent on observations. And of course when you're looking at read Aristotle, you think, well, some of the so-say observations you made were incorrect. But basically one of the fundamental observations is it looks like moving and it's the sun that's moving. So if you're going to build up a logic system of science based upon that observation, then you are quite happy. But Galileo brought that observation into doubt by trying to provide evidence that the Earth moved around the Sun, and it's really more accurately they're moving around a common centre of gravity. So what you're faced with is if you could not rely on the observation that the Sun moved around the Earth, what observations could you rely on? And the answer was you couldn't rely on anything. Reality we perceive is different to what our senses of sight, sound, touch, etc. tell us. So you've got this fundamental problem. If you can't rely on that observation, what your senses are telling you, you can't rely then on anything your senses are telling you. So back came the idea of atoms, and atoms goes a long way back to Democritus, and based upon normal observations in daily life, nobody's seeing any atoms. So it's not really a theory based upon observation which you could make back in those times. And so when they're looking at a theory which could be based on atoms, what type of atoms did they decide upon? And the answer was they decided that the atom was a point particle. And this is meaning atom in the context of a particle you couldn't split to something smaller. When you've got a point in maths, you can't so say split that any further down. So you're identifying the smallest particle in physics as a point particle. So really, modern physics is based upon the idea of point particles, and it goes against our feelings of common sense, so therefore it becomes an existential crisis. So presumably one of the reasons it is omitted from most physics courses, i.e. teaching about the theory of point particles, is because the human way to cope with an existential crisis is to ignore it and pretend you don't have one. So from my observations of people, when they've got a problem, often if it's too big and they can't think of any way around that problem, they try to skip over it and carry on in their thinking process. And sort of like physics is sort of like the same thing. When they're teaching physics to people, they're sort of like, there's a problem with something, they don't want to go into too much details about it, so skip over it. And it's the same thing with this point particle theory. They talk about point particles when you've been taught physics, but they don't go into the details of what the theory is behind the point particles, because it would cause problems. So skip over that. And they skip over that, and any other problem they come along which is too deep, they try to skip over that as well. So this is the education system and the way people kind of cope with things which they can't deal with. So at the fundamental level of the Copernican revolution, it led to this bringing back the theory of atoms, and the theory which modern science decided to base itself upon was this gives this existential crisis. You try to think about point particles. If you think about it too much, it doesn't really make sense because it's not conforming to your senses. When they start talking about things, this table and so forth, made of particles, and most of it's empty space. 99.999% of it is not there, and that does not correspond to what your senses are telling you. But you're supposed to look at it in closer and closer detail with things like electron microscopes, and you see beyond your senses. So, the father of modern atomic physics was this person. It's Father Boscovich. And so you've got one theory which doesn't properly make sense, and go forward a bit and add a bit more to it.
No, but that is contradictory what you said before. What I understood what you said before was you go along, the thing that doesn't make sense, you discard it all and start with a new theory. That is what you said before. Now what you're saying was, which is what basically we all try and do. We build up the theory. Okay, now it's, modern physics is building on foundations that have been laid up to, in the 1900s to 1950. Those are the foundations that everything is built on. But before that, what I understood what you said was that something was there, but thrown overboard, and something new started.
The big fundamental one was with Galileo.
Correct. But that is physics. If somebody comes today and brings forward a theory that just the whole thing could fall, and we'll start on a new theory. The physics today, as we understand it, could tomorrow or the day after tomorrow fall completely, and we build up a completely new mathematical model.
Well, I say the fundamental within modern physics as to what they're building upon is this idea of point particles, and it's very difficult to discard that idea. If you're talking about a theory which is going to discard that, then it's really something that's used a great deal. So there's kind of restrictions on what you're allowed to discard, so you can add to it and come up.
First, thanks very much for the presentation. Terrific stuff. You gave both the background in the authority system behind it and the content in the sense of this ripple of force that seems to be so universal there. I just would like to add the remark that if anyone who's not been aware of it, my approach to the particle, the infinitesimal particle thing, and the problem of force are both addressed, and doing the simplest model I can that doesn't allow those, produces eigenfunctions with radial ripple, which although they're not a force function, they do confine the electron in these bands of radius. Okay? So it sort of fits with the
point particle theory.
Boscovich's, yes, except we don't need a point particle. Because all I'm saying is we don't like the point particle because it offends us with the infinities.
Yeah.
And we also need something to deal with its geometry around the atom. And with what is the simplest wave process I can put together as being fundamental, it produces that. And it's believed not to.
Yeah. But with, as I say, Dragoslav, when you develop the point particle theory, it does get more complicated, and it does evolve to quantum physics.
Okay,
but if you're going to address the issue where you want something to replace point particle theory, well, one of the biggest problems is it's not taught. They've omitted it, they've jumped over it. So you've got physics people.
It's like you were saying,
so
people haven't seen how you might go about or not showed sufficient push to deal with that problem.
So something like Wittgenstein said, what we don't talk about, we move over in silence. So the point particle theory, they don't talk about it.
Right.
So nobody's discussion the issue of should we have this
So my
parking?
claim is that I have faced it.
So they're just avoiding teaching it, so nobody's talking about any problems with it.
Indeed, I think your picture was terrific.
Yeah.
Okay, can I suggest that Roger kindly stop this talk early. Let's get back on track.
Okay. Thank you.
And